In this video, I'd like to talk a little bit more about unpacking sequences of values. Now, back in the preceding lesson, we introduced tuples for the first time, and in the context of a dice rolling application, the dice game Craps, we had a roll dice function which returned to us a tuple containing two die values. And in order to access those individual values, we unpacked the tuple, which gave us the two individual values which we could then use in our code. So let's revisit that, because you can actually use that technique with any sequence type. So here I've pasted in a tuple called student tuple, which contains two elements, the string Amanda and a list of integer grades for that student. Now, as we demonstrated previously, you can go ahead and unpack the tuple. Usually you'll do that into variable names that have some sort of meaning associated with that data. So let's say we had first name and grades as the variable names that we want to use here, and we're going to assign to that the student tuple. Now, before I execute this, I just want to reiterate that the comma-separated list of variable names that you have here on the left side of the assignment must have the same number of items as there are elements in the tuple. Otherwise, you'll get a compilation error, which you'll see in the self-check exercise associated with this video. So let me go ahead and execute that, and let's now display the value of first name so that you can see the first element got assigned to the first variable, or unpacked into the first variable, I should say. And grades, of course, is the list of grades in this case. Now, like I mentioned, you can do this with different types of sequences. So let me paste in another snippet of code here. In this case, we have the string hi, which has two characters in it, and we can pick off those two characters very easily by using the unpacking concept. So here's a print statement in which we have two placeholders in our F string, first and second, and we're just going to display the two characters separated by a couple of spaces, and you can see that indeed we were able to extract the individual elements in that case. And of course, it will also work with lists. So here is another snippet. In this case, we have a list of 3 integers and, of course, 3 variables on the left side of the assignment to ensure that we extract those values properly. Let's go ahead and print those out individually here. So here's just another print statement with 3 placeholders in it, 1 for each of the variables. And of course, we can now see the individual elements have been extracted there. Now, we can also go a step further with this, and again, this will work for any sequence. So here is a statement in which we are creating a range of integer values. Remember that the range function we typically use in a for loop to specify a range of values over which to iterate. Here we want to start with the value 10. We want to produce values up to but not including 40, and we want to increment by 10 each time. So we're going to get 10, 20, 30 as a result of this particular range. That is a sequence of integers, and any iterable entity that can give you individual elements like that is capable of being used in this unpacking scenario. Now here we know that we're going to get 3 elements, therefore we have 3 variables, and once again I'll just copy a print statement in here so that you can see that indeed we are able to unpack a range as well. Now let's consider another way in which unpacking can be used. This one is actually one of the cooler features that I like about tuple unpacking. So let's assume we have a number called number 1, and it's got the value 99, and number 2, and it has the value 22. When we're doing things like shuffling a deck of cards, one of the things we often need to do is swap 2 elements in a collection. Well, it turns out that you can implement swapping in Python in a single line of code by using packing and unpacking. So take a look at this statement here. On the right side of this assignment, we are creating a tuple containing the variables number 2 and number 1. And on the left side of the assignment, we have those same variable names in the reverse order, number 1 and number 2. So what happens here is first we pack into a tuple the values 22 and 99, because it's number 2 then number 1. And the value number 2, which is 22, gets placed into the leftmost variable here, and the value of number 1, which is 99, gets placed into the rightmost variable. So by simply placing the variables in comma-separated lists on both sides of the assignment, we can instantly swap those two values via packing into a tuple and then unpacking from that same tuple. So let's go ahead and execute this statement. And of course, just to prove that in fact the values were swapped, let's throw in a print statement here. Once again, we're using a format string, and we're going to display the value of number 1 followed by the value of number 2. And now we can see that number 1 is 22 and number 2 is 99. So we did in fact accomplish the swap in this case. Now, one last thing that I'd like to look at in this video with respect to unpacking specifically tuples is a function that's built into Python called enumerate. You may recall from the first video of this lesson about lists that one of the things we could do with a list was iterate over the elements, accessing each individual element via its index number. So we displayed a little two-column format excuse me, in which we had the index number in the left column and the value at that index in the right column. Well, it turns out that there's actually a slightly better way to implement the loop that we demonstrated to you in that example. So first let's talk about the enumerate function, and then we'll show you a similar loop. So for this example, I'm going to use a list of strings, 3 strings in particular, red, orange, and yellow. And now that I have that list called colors, what I would like to do is associate each of these objects with its index in the list. So take a look at this expression that we're going to write here, list enumerate colors. So what's going to happen here, first of all, is the enumerate function is going to generate a sequence of tuples in which each tuple contains 2 elements, the index number and the value for the corresponding element in the colors list. And then for the first time, we're showing you the list function that's built into Python. And what this function is going to do is take the sequence you give it as an argument and turn it into a list object. So let's execute this, and you can see that this list function is returning a list. That's the set of square brackets that you see in the string representation. And inside of that list we have a tuple containing 0 and red. Red, of course, is at index 0 of the original list. Then we have the tuple 1 and orange. Orange is at index 1 in the original list. And then we have 2 and yellow. Now the reason enumerate is handy in this way is it guarantees that we get the proper number of tuples with the proper index values associated with each object in the original sequence. If we are not careful when simply using the range function, which is what we did earlier to iterate through a list index position by index position, we could generate the wrong length range, and in that case we could potentially wind up not iterating over all the elements of the collection we want to process, or we might go past the end of the collection and wind up with an exception at runtime. So we can also, in addition to creating a list of these tuples, we can create a tuple of these tuples. So we could have said tuple enumerate, whoops, there we go, colors, and when we execute that we get the same result, except this one is a tuple and thus surrounded by parentheses in its string representation. So now that we've seen what the enumerate function does, let's use this in its most common scenario, which is in the context of a for loop with tuple unpacking. And we'll use this technique a number of times in later lessons as well. So when we create a for loop, normally we have a target variable after the keyword for. However, when the right side of the in keyword is giving us tuples of values, we can put a comma separated list after the for keyword to unpack the tuple. So let's say we want to unpack each of these tuples into index and value, and we're going to do that for each tuple in the result of calling enumerate colors. Now, again, enumerate is going to produce this list of tuples one element at a time, one tuple at a time, or I shouldn't call it a list, I should call it a sequence of tuples one element at a time. And for this one, let's go ahead and paste in a print statement that's simply going to display the value of the index, a colon, and the value of variable value. So if I execute this for loop, you can see that we get the nice 2-column output, 0, 1, and 2 for the indices, red, orange, yellow for the values in the original list. And guaranteed, because enumerate figures out the length of colors for us and generates the indices for us, we are absolutely guaranteed that we will only get the correct indices, the correct number of indices, and the correct corresponding elements for those indices.